So our course today is going to be about how iPhone 6 Wi-Fi circuit works. Wi-Fi is a type of technology that enables electronics devices to connect a wireless local area network. There are two radio wave frequencies used to ensure the working of iPhone 6 Wi-Fi, 2.4G and 5G. Wi-Fi signals of different networking standards vary in transmission rates, and they all should run on one set frequency based on standards. First, let's take a look at the main components on Wi-Fi circuit. U5201RF, Wi-Fi and Bluetooth module. Data transmitted from CPU is first coded by the module, then translated into a certain radio signal. This same signal will then be transmitted via the antenna. The Wi-Fi signal received will also be demodulated, decoded by the module into raw data and then be sent to the CPU for further process. U0201 CPU, which works to control the Wi-Fi module, and its communication with Wi-Fi module via PCIe bus, also completes the network information transmission work. U1202 PMU, Power Management IC. It provides power supply, clock signal, and enable signal to Wi-Fi module. Now let's find out how iPhone 6 Wi-Fi circuit really works. First, voltage of the battery is transferred into PPVCC main by means of Q1403. The voltage is then set to the Wi-Fi module. Once the phone has been turned on, PMU will output the 1.8 volts power supply to the Wi-Fi module, and then a clock signal at a frequency of 32.768 K. With the Wi-Fi being turned on, PMU will send a register and enable signal to the Wi-Fi module so as to get the Wi-Fi module activated. By means of its inner circuit, the Wi-Fi module will then form a box circuit with L5201RF. The 1.35 volts voltage generated by the box circuit afterwards can be used for internal application of the module. It should be noted that if the phone is in standby mode, the voltage generated by the box circuit will be 1.1 volts. Next, CPU have to get the PCIe bus function of the Wi-Fi module activated. To enable the function, CPU needs to send a reset signal of the PCIe bus and the wake signal of the PCIe device to the Wi-Fi module. With the two control signal received, the Wi-Fi module will then enable the PCIe function and ask CPU to provide clock signal necessary for normal work of PCIe. Once the reference clock signal of PCIe has been sent to Wi-Fi module by CPU, PCIe bus will then get to work. CPU sends data like underlying driver and network information to Wi-Fi module via WLAN PCIe TXD. On the contrary, the Wi-Fi module sends the data received to CPU via WLAN PCIe RxD. Please be noted that since the underlying driver of Wi-Fi module is stored in NAND flash chip, exceptional data of the NAND flash chip can result in not working of Wi-Fi. This kind of issue can be fixed by NAND flash chip repair. The Wi-Fi module captures Wi-Fi signal first, then inform the CPU of the result via PCIe bus, and ask users to enter the password for the Wi-Fi signal of its choice. If the Wi-Fi signal received by the phone has been accessed before, and relevant info has also been stored in the NAND flash chip, the NAND flash chip will send IP address and password of the Wi-Fi signal to the Wi-Fi module. The Wi-Fi signal is then decoded by Wi-Fi module automatically, and the Wi-Fi network will be connected automatically. There is no need for password entering once again, with the phone being connected to Wi-Fi, but in sleep mode. if there is notification or alert message, the Wi-Fi module will send a host wake up signal to PMU, and screen of the phone will then light up. If the host wake up circuit goes wrong, with the screen being black, we won't be able to awake the screen with power button. Also on the Wi-Fi circuit, antennas at frequencies of 2.4 GHz and 5 GHz are responsible for signal receiving and sending. Wi-Fi signals at frequencies of 2.4 GHz access the phone via antenna, then go into the combiner by means of a matched network. The combiner will then send the 2.4 GHz Wi-Fi signal into Wi-Fi module. Wi-Fi module restores the signal into data to be processed by CPU. Then the data will be sent to CPU via PCIe bus. Since a lot of devices run at frequencies of 2.4 GHz, to avoid insufficient of the transmission channel, frequencies of 5 GHz has been added for Wi-Fi transmission of the phone. Wi-Fi signal at frequencies of 5 GHz goes the way like those of 2.4 GHz. It goes into the phone via 5 GHz antenna first, and then the Wi-Fi module after filtering process. Compared with Wi-Fi signal at frequencies of 2.4 GHz, those of 5 GHz has a higher frequency, and therefore accompanied with serious signal attenuation and low penetrability that have a low level of interference with devices around. In this way, more Wi-Fi signals can be held in the same area. As IEEE 802.11ac provides WLANs on the 5 GHz band, it has a higher rate of transmission than other standards. When the phone is accessing Wi-Fi signals provided by IEEE 802.11ac at frequencies of 5 GHz, users will have the impression that Wi-Fi signals at frequency of 5 GHz run more smooth than at 2.4 GHz. Now let's move to detecting and repairing of iPhone 6 Wi-Fi circuit. Once we have confirmed that the fault has nothing to do with external causes, like network, Wi-Fi compatibility, or router problem, network setting of the phone, software version, or exceptional data of NAND flash chip, we should run cosmetic inspection of relevant area on the board. If the fault shows up as a signal problem, like weak signal or unstable signal, we can take one level of tweezers as an external antenna and connect with nodes on the antenna circuit one by one. If the signal strength is back to normal with one specific node, then the fault component is the one connected with the node. If all nodes fail, then the Wi-Fi module might have been damaged or pseudo-soldered, and we need to replace or rebuild the Wi-Fi module. As for other problems related to Wi-Fi circuit, first thing we do is to measure the 3 voltage of Wi-Fi module. PP-VCC main 4.2 volts, PP1V8, SDRN 1.8 volts, and L5201RF 1.35 volts or 1.1 volts. If nothing goes wrong, then detach the Wi-Fi module from the board and run diode measurement of the corresponding bonding pad. If the measured value of all bonding pads is normal, then replace the Wi-Fi module. If the measured value of one specific bonding pad is abnormal, then check relevant circuit of the pad. Common fault components of the Wi-Fi circuit. Damage of U5201RF can result in issues like weak Wi-Fi signal, no Wi-Fi signal, Wi-Fi activation failure or Wi-Fi connection failure. Damage of FL5201RF can result in weak Wi-Fi signal, unstable Wi-Fi signal, etc. And this is our detailed explanation of how iPhone 6 Wi-Fi circuit works. Feel free to visit our official website, www.rivatechnology.com. See you next course.